Today we'll be talking about voltaic cells. We'll have zinc reacting with silver. So first, you draw it all out, and then you have a zinc on one side and a silver on the other. Then you look at the standard reduction potentials, and you list them, and whichever is the most positive is the one that's going to be reduced. And then to find the E cell, you get the formula E cell equals E reduction plus E oxidation. Plug it in. Before you do that, you have to make sure that you switch the sign, because this is the reduction half, potential, so you have to flip it to get the oxidation. So then you plug it in, you get the E cell, and in this case, it's the E cell is positive, so the delta G is negative. So this is a TFT. And also, I do that because oxidation is losing, it's losing electrons, reduction is gaining, and NOx, that's why this is the anode, and red cat, that's why that's the cathode. And then as the reaction's occurring, the SO42 negative is going to the zinc side to make up for it, to keep, this is like a salt bridge first. And without this, nothing will happen. It'll be at 0 until you put the salt bridge in. If it knocks over, it'll go back to 0. But basically, when it starts, it doesn't keep it neutral. It'll send SO42 negative over here to balance out, and vice versa. They'll send the Na over here to balance out. And electrons are flowing right here. It always flows from anode to cathode.
We all know that the standard for molarity is 1 molar per liter. Now let's say you don't have this. Let's say you have 0.6 molarity in your anode and you have a different one. Let's use a standard 1 molarity in your cathode. So what happens here is the zinc, since it's your anode, it wants to form more ions. And what happens there is the zinc will reduce in mass and it will form more ions. Now, since it's forming more ions, it will create more electrons to send over to the cathode. And as that happens, your V value, which is your voltage, will increase. And since your cathode is gaining electrons, what happens is the Ag plus will want to form more Ag solid. So what happens is your molarity in this, for the aqueous solution, will actually go down.
Here you have electrolytic cells. Electrolytic cells are different from galvanic or voltaic cells because in this case, we need the current to flow into the cell in order for the reaction to occur. So here we have calcium bromide. In this case, calcium is the cathode and it's reducing, and bromide is the anode and is undergoing oxidation. And another thing that makes electrolytic cells unique is that their E cell is different. It's kind of different. So as usual, we do the E cell is equal to the E reduction of the E oxidation. But in this case, since electrolytic cells are non-TFP, the E cell is going to be negative, and that would make the delta G positive. Because in delta G, we need to multiply the E cell by Faraday's constant and the number of most electrons, excuse me, and we need to multiply that by a negative. In this case, the two negatives will cancel out, leave us with a positive delta G, which we all know is non-TFP.